I welcome you all to the Spark Research YouTube channel. This is Dr. Vishchandra, Assistant Professor in the Department of ECE. This is another session from this course, Electronic Devices, and in this session we are going to take some questions which has already been asked in GATE 2024, right? So this is the second part of this GATE 2024. So if you want to visit the first part, I have already dropped the link in the description section. You can find it and you can visit, right? So here is the overview of the GATE. So typically the questions may come in the range of 6 to 10 marks in all the years of the GATE. So this is very important to score the marks in this particular course, and this is also very easy, right? Here is the syllabus for this electronics devices from the GATE only I have taken, so you can follow these courses and you can go through the Milman Halkia's book for the information, and you can go through the contents. Okay, so let's take the question. First of all, this GATE 2024 has been organized by IISc Bangalore only. And so let's take the question number 64. So what is the question? An MOS transistor operating in the linear region has IDS of 5 microampere at VDS of 0.1 volt. So remember, whenever it is talking an MOS transistor, now mostly they are talking about the enhancement type, right? And so there are the two reasons. One is linear and one is saturation. So they are talking about the linear, means channel is forming. So complete channel did not form, right? So keeping VGS constant, the VDS is increased to 1.5 volt, right? So gate voltage is constant, we are going to keep, and VDS we are only increasing, right? Given that is mu cox WIL, that is K is equal to 50 microampere per volt square, the trans conductance at new operating point is being asked trans conduction, right? So first of all, if it is in linear region, then what will be the current equation? So that is the IDS is equal to mu cox W by L, and so here we can use this equation. IDS is equal to mu cox W by L, VGS minus VTH into VDS minus of V square ds by 2. In saturation region, what it will become? So in saturation region, you have to replace your VDS is equal to VGS minus VTH. So in that case, your equation will become some mu cox W by L and VGS minus VTH whole square by 2, right? But in this case, since the question is being asked related to the linear region, so we will use this equation, right? Transconductance, actually in this question, transconductance has been asked. So what to do here? Transconductance, that is Gm, is di by dv, right? So here current is IDS divided by VGS, right? So that will be equal to mu cox W by L and into VGS minus VTH. So we'll use this equation to find out the value of transconductance. As per answer key provided by the IC Bangalore, your answer should be in the range of the 15.40 to 15.60. So let's see the more details of the solution. So here NMOS transistor is here, like here you can see this is a drain and this is your source and here is your gate. So basically gate will control the flow of your electrons from source to drain, right? So the amount of the current that will be the depending on the VGS that you are applying across the gate, and definitely VDS that you are applying across the drain. So this is a formula which is being used to find out the current in the region, that is K. K is nothing, K is mu cox WIL, and VGS minus VT into VDS minus of V square ds by 2, right? So let's see the more detailed explanation of this question. So IDS, this is your IDS is given 5 microampere, VDS is given 0.1, mu cox WIL is given 0.50 microampere per volt square. So put all these values in this equation and get the value of VGS minus VTH, right? So that will be equal to 1.05. Once we'll get the VGS minus VTH, then we can find out the transconductance. Transconductance, as we know, equation is di by dv. So mu cox WL VGS minus VTH. So already mu cox WL it has been given, that is K, that is 50. So replace this value by 50 and VGS minus VTH we got with this relation. So put these values and finally transconductance is 15.5 5 microampere per volt. Right? Okay, let's take last one more question. So in this question 65, the photocurrent of a PN junction diode solar cell is 1 milliampere. Right? The voltage corresponding to its maximum power point is 0.3 volt. If the thermal voltage is 30 millivolt, the reverse saturation current of diode is being asked here, right? So what is the first of all, how can we find out the current? So normally the current across the diode we can find using this formula, that is ID is equal to I naught exponential of Vd divided by eta Vd. So Vd is the voltage, forward bias voltage, and eta is normally constant 1 or 2. Ideally it's a 1, and Vd is the thermal voltage, right? So with the help of this equation you can find out the current across the diode. But in this case one photodiode is also there, so you have to find out the actual current, so that will be the difference in between the diode and the photodiode, right? So here is the circuit. This is a photodiode, and so ID is already passing, so now we have to find out the net current, that is difference of this, right? So your answer should be in the range of the 4 to 4.26. Let's see the some more detailed explanation. So we'll use this equation only to find out the value of your current, that is I is equal to IL minus IS exponential of Vy eta Vt minus 1, right? So this is your something like PN junction diode. Photodiode is also an example of PN junction diode only. There is no special term. So like that's why we can use this current equation, which will be valid here. So we are going to use one equation. So before going it, you can like go through this explanation, that is how can we find out the final current equation. So power can be written as the V into I, and the maximum power, that is dp by dv, is equal to 0. In order to maximize, you can find out the relation, that is dp by dv. If you will make it equal, then you will get the relation, that is iph is equal to I naught and v of e to the power v divided by vt, and divided by vt exponential of v by vt, right? So finally we can use this equation to find out the value of the current. So here we are going to use this equation, IL divided by I naught plus 1, that is IL y naught is equal to exponential function Vm by Vt 1 plus Vm by Vt. So Vm is given in this question, that is 0.3. Thermal voltage is also given 0.03, that is 30 millivolt. Photocurrent is given 1 milliampere, right? So put all these values and you can get the final value of the current I naught, right? So if you'll break and then if you'll solve it, you will get the final value of current, that is I naught is equal to 4.1272. So actually your answer should be in the range of the 4 point in the 1 3, right? So that's all in this session. We'll come with some more questions in another session. Thank you to join.